Hello everyone, my name is Aitor. I'm a PhD student here at the University of Valladolid, and in the last years I was working in the group of forest modeling and quantitative silviculture. And today, through my presentation, I would like to give you an overview of the topics we are working on and the possibilities of application that they have. To do that, I divided my presentation into 5 different topics, and I would like to start for few definitions. I'm sure that all of you have heard about models, modeling, and so on, and maybe you have a more or less clear idea about that. But just in case, a model is an abstract representation, an idea of an object or a process, and used to be represented in a mathematical way through an equation. And we are using models all the time, even if we don't think about that. And one clear example is the weather forecast. Using models, we can predict the daily temperature and its evolution during the day for different places, applying different models. In forestry, it works the same. So for instance, to predict the stem biomass of a tree, we have different models by species, and introducing the measurements of our trees, we can predict the biomass of our stem. And then the difference between a model and a simulator, they are similar, but they have differences. While using a model, we can predict normally just one thing. Using a simulator, we can combine several models in a logical way and predict more than one thing, so have more results that normally they are related among them. Coming back to our weather example, we can predict not only the temperature, but also the rainfall, humidity, and so on. And coming back to forestry, we can predict the tree biomass, tree volume, and processes like growth, mortality, and others. And now the question is, okay, all of that processes are natural processes, but can we predict the human effects? And let me introduce that idea with an example. Imagine that we have a forest that looks like the one of the left side, and our goal is to manage our forest and get the structure of the right side. So ideally, the easier way, the easier silviculture is a straight line where we spend less effort, less money, less time, and so on to reach that goal. But then the reality is that depending on how we are applying that silviculture, we can reach different points or spend more effort than what we require to reach the same goal. And the question here is, can we somehow guess which is the ideal silviculture before to apply it? And the answer is yes. And we can do it using tools like forest management simulators, as it is CIMAN4. CIMAN4 is a tool available online that integrates different forestry models, and it can be used to develop and compare and rank different management guidelines that better fit our objectives. And it's really interesting for those case studies where we don't have previous expertise on, and we don't know exactly what's the better way to manage our stand. And to illustrate that idea, I'm now going to pass through 3 different topics where we applied that tool. The first topic is about irregular stands. In the left side, we have the traditional way to manage forests. For instance, if we think on a plantations, all the trees have the same size. And in the right side, we have a irregular stand, where we combine trees of different sizes, and the management can be a bit more complex. Using CIMAN4, we tested different management silvicultures and we developed different management guidelines for Quercus pyrenaica, which is a Mediterranean oak here in Castilla y León. The past and the present of that species is that more of the stands are regular copies stands. They have no management, and the conditions are a bit bad of that stand, so the products we can obtain are a small size and mostly used for firewood, and the productivity of the stands are low. While if we transform through silviculture data stands to irregular ones and we find a better management approach, we are able to obtain higher timber products that can be used on industry, so the profitability of our wood is higher, and also the productivity of the stand increases. And that is just a matter of applying the proper silviculture, that transformation. Irregular stands are one example, and now each time we are hearing more about mixtures because they are more resilient, more resistant, and so on. And traditionally, our stands were managed, if we think again on a plantation, we have normally just one species on the stand. On mixed stands, we used to combine 2 or more than 2 species, so the complications on management are a bit different. And before to go to the management part, we wanted to understand, to compare mixed stands versus pure stands and to understand which kind of forests are able to sequester more carbon. To do that, we studied 4 species mixtures, Pinus sylvestris combined with another 2 conifers and 2 broadleaves, and our goal was to simulate 100 years of natural growth and to compare the carbon sequestration on mixed versus on pure stands. And that are all the results we have. In the x-axis, we have that growth of 100 years. In the y-axis, we have the carbon sequestered. And in the gray or black boxes, you have the evolution on carbon sequestration of the mixed stand. And you can see more or less that mixed stands in all the mixtures we studied were able to sequester more carbon than the pure ones. That means that when we combine more than one species in our stand, there are some complementarity effects and the productivity of the stands are higher. And then another implication of the management is our targets. So normally, when we think on a silviculture, we are thinking on to get one goal that can be, for instance, to promote the timber productivity. But now we are more thinking into multiple management targets. So we can have a good, for instance, fire prevention, we can promote the carbon sequestration, we want to collect fungi, we want timber, we want a lot of things. And we cannot have everything at the same time. So to assess how it works, we studied the trade-offs, so the gains and losses of different silvicultural approaches on a given stand mixture. For this study, we selected just the Pinus sylvestris, Pinus pinaster mixture, and what we studied was the carbon sequestration, the fungi productivity, and the production of timber products of big size and small size. And what we wanted was to assess the gains and losses of different silvicultures among all the products. So for a given species proportion, we found that while in some silviculture approaches, like the case 1, we can just promote one product. Following another approaches, like case 2, we can promote more than one product at the same time. So multiple targets in forest management are possible. But then we have another question. We are studying a mixed stand, and we can have different proportions of mixed stands, and even we can have parts, gaps, let's say, of pure stands. So does that silviculture works in the same way, or we will have different results? And the results we found was that applying the same silviculture but having different forest initial conditions, the results will be different. So silviculture must be adapted to the conditions we have. And just to summarize and to finish my presentation, I have 2 take-home messages. As I said, silviculture must be adapted to each case study, as we saw in the 3 different topics you hear here. And models and simulations can support the decision-making processes, in that case, focus on forest management. And that's all from my side. Thank you for your attention.